For billions of years, the Earth has recorded its history in discrete, predictable layers of rock, sand, and bone. It's basically been this massive geological diary written in the slow-motion ink of sedimentation. But recently, well, something absolutely impossible started happening. We're observing the emergence of anomalies that completely defy conventional natural history. The planet is no longer just this stable, passive environment. It's been transformed into a highly reactive, dynamic chemical reactor. So welcome to this explainer, because today we are diving deep into the creation of a brand new geological reality. We are currently burying synthetic artifacts into the Earth's crust at a velocity that makes the asteroid impact that erased the dinosaurs look like a minor tremor. And this brings us to a massive, fundamental question, one that we really need to pause and think about. What happens when you overclock the biological engine of Earth? What actually happens when a single species overwrites the planet's baseline chemistry? We're about to look at the exact mechanisms of how we've done this. And trust me, the sheer scale of our permanent footprint on the deep time timeline is going to absolutely blow your mind. To really wrap our heads around this chronostratigraphic alchemy, we're going to break this explainer down into 4 chapters. First, the new geologic golden spike. Second, plastics and the dissolving oceans. Third, synthetic ecosystems and planetary metal blenders. And finally, we'll take a look far, far into our deep time geological archive. Okay, let's jump right into Chapter 1, the new geologic golden spike. We're looking here at the invisible chemical overwrites fundamentally altering the planet. To grasp the scale of this shift, we first need to define the stratigraphic golden spike, or GSSP. Basically, this is the specific geographic location where geologists agree that one epoch ended and a new one began. Now, traditionally, these markers are entirely natural, like a sudden change in fossilized pollen or a huge shift in the Earth's magnetic polarity. But today, our marker isn't a fossil at all. It's isotopic. Following the thermonuclear tests of the mid-20th century, this massive pulse of cesium-137 and plutonium-239 was dispersed across the entire globe. It created a precise, world-spanning layer of radioactive dust. I want you to imagine a chef sprinkling a distinct, glowing, neon-colored powder all over a giant wedding cake. No matter where you cut a slice of that cake, you know exactly when that specific powder was added, right? Well, this radioisotopic horizon acts as our planet's permanent, undeniable timestamp. It signals that humanity has successfully and permanently overwritten the geological timeline of the Earth. And the crazy thing is, we didn't stop our radioactivity. The very chemical composition of our soil is being completely rearranged by something called the Haber-Bosch process. This is the industrial method of fixing atmospheric nitrogen into ammonia for fertilizer. Now, before the 1900s, nitrogen was a huge bottleneck for biological growth. It was tightly controlled by natural lightning strikes and specific bacteria. But by synthesizing it on an industrial scale, we've effectively doubled the amount of reactive nitrogen entering the Earth's terrestrial cycle. Every single time you look at a lush green agricultural field, you are looking at a massive planetary-scale chemical experiment. Think of the Earth's biological engine like a highly tuned car engine. It was designed by nature to run on a very specific, carefully measured fuel mixture. By industrializing nitrogen, we didn't just add a little more gas. We essentially injected 10 times the amount of highly combustible nitromethane directly into the cylinders. So the machine still runs, but it runs hotter, faster, and much, much more dangerously. This extreme chemical overclocking leads directly to things like runaway algal blooms and massive oceanic dead zones. And in the future sedimentary record, these aren't just going to look like temporary biological events. They will be recorded as dark, oxygen-starved scars permanently etched into the rock. Which brings us to Chapter 2, Plastics and Dissolving Oceans. This is where those invisible chemical changes escalate into highly physical, permanent alterations of the crust. In the natural world, lithification, which is just the process of loose sediments turning into rock, is an incredibly slow, tedious process. It's akin to a librarian carefully organizing books on a shelf one by one over centuries. But the introduction of industrial byproducts has violently accelerated this clastic cycle. We are literally creating a brand new category of geological formation called plastiglomerates. These are hybrid rocks formed by the melting of plastic debris, sand, and organic matter, usually during beach fires or industrial accidents. To really visualize this, think of a sculptor accidentally dropping a bag of colorful glass marbles into wet concrete.
Once that concrete sets, the marbles aren't foreign objects anymore. They become permanent structural components of the slab, forever encased in the stone's history. Because plastics like polyethylene don't biologically degrade, they just fragment into tinier and tinier microparticles. They are now being permanently integrated into the silts of river deltas and the actual skeletons of marine life. A million years from now, a cross-section of the Earth will reveal a colorful, indelible stratum of plastic resins, a synthetic sandwich demarcating our era of manufacturing. It's kind of darkly comedic to realize that a discarded plastic spork might actually outlast the ruins of the Roman Empire as a geological marker.
And that ties right into the profound disequilibrium of the carbon cycle. By liberating sequestered carbon from fossil fuels, we are drastically altering the pH of the global oceans. When atmospheric CO2 dissolves into seawater, it forms carbonic acid. This acid actively reduces the availability of carbonate ions, which, if you don't know, are the essential building blocks for calcifying organisms like corals and mollusks. This is an absolutely terrifying mechanism when you think about it. It is the exact equivalent of trying to build a brick house while the bricks themselves are slowly dissolving into a fine powder right in your hands. As the ocean becomes more acidic, organisms forming the base of the marine food web simply cannot maintain their calcium carbonate shells. So future geologists won't just see a change in fossils, they're going to note a great thinning, a sudden, sharp decline in shell density, resulting in a ghostly silence in the sedimentary layers where complex life once thrived. All right, let's move to Chapter 3, Synthetic Ecosystems and Metal Blenders. We're escalating from physical rocks to bizarre biological mutations in urban crusts. Consider the metal enrichment horizon. For millions of years, the Earth filtered and separated its raw materials into neat, concentrated, very deep veins. But through mining and heavy industrial metallurgy, we've basically thrown the entire Earth into a chaotic global blender. We are effectively taking rare earth elements and heavy metals, things like cadmium, lead, and mercury, pulling them from their deep, stable geologic vaults, and scattering them across the active, living biosphere, like confetti at a parade. This isn't just some temporary spill, it's a permanent geochemical anomaly. It's a chaotic, homogenized layer of industrial heavy metals that is going to remain present in the Earth's crust for tens of thousands of years. But life, astonishingly, is reacting to this. The interaction between these synthetic materials and natural microbes has birthed what's called a plastisphere. This is a specialized ecosystem where bacteria and fungi are actually evolving to colonize and break down the synthetic plastic surfaces. This is not just environmental pollution anymore, this is a literal evolutionary shift. Imagine a forest where, instead of trees, the primary producers are plants that have evolved to consume discarded electronic waste. The planetary chemistry is actively adapting to our pollutants, creating this wild feedback loop between synthetic waste and organic evolution. And honestly, nowhere is our physical footprint more obvious than in urban stratigraphy. Major cities, they are no longer built on natural soil. They sit on an engineered crust called anthropogenic fill. This is a deliberate mix of crushed brick, glass, bitumen, and rebar that can easily be dozens of feet thick. It's kind of like living in a house raised on stilts, but the stilts are made entirely of compressed trash and historical debris. Eventually, this is all going to solidify into a highly unique conglomerate rock. Imagine future paleontologists finding a spark plug permanently embedded right next to a 21st century coin, just trying to understand this bizarre technological metabolism. Which brings us to our final chapter, our deep time geological archive. Let's shift the timeline forward to look at the existential, deep future analysis of our epoch. Out in the agricultural heartlands, persistent organic pollutants, chemicals that were specifically designed to resist decay, are folding deep into the sediments of our freshwater lakes. They act as chemical ghosts. I want you to picture a single drop of dense, black ink falling into a slow-moving river. Even after that river travels for miles and the water appears crystal clear on the surface, those ink molecules are still there, moving in the dark sediment, just waiting to be unearthed by future analytical techniques. These non-degradable markers are permanently tied to our land use history. So the crucial takeaway here is that these shifts are highly systemic. By covering vast swaths of the planet in dark, heat-absorbing asphalt and concrete, we are fundamentally altering the landscape's albedo, which is its reflective power. This is the urban heat island effect, but on a massive planetary scale. It is exactly like the Earth wearing a thick, heavy wool coat on a sweltering hot summer day. the planet holds on to thermal energy far longer than it ever would under native vegetation. The Earth is effectively running a planetary fever, and that elevated thermal signature is actively changing chemical reaction rates right there in the soil. So you might be wondering, how will researchers actually study us in the deep future? Well, they won't use traditional carbon-14 dating. Fossil fuel emissions have distorted the carbon baseline so severely, a phenomenon known as the Suez effect, that our carbon emissions have diluted the natural radioactive carbon in the atmosphere, making traditional dating totally useless for this era. Instead, future geologists are going to have to rely on a technofossil chronology. They will map the rise and fall of our civilization by measuring the density of iridium, the exact layers of manufactured micro-polymers, and sudden, sharp shifts in strontium isotope ratios. We are currently engraving our entire cultural history into the planet's future substrate. We've transitioned from merely being inhabitants of the Earth to becoming its primary geological agents. We must transition from a model of endless extraction to one of deep time stewardship. Because the geochemical record, it is the ultimate, final auditor of human behavior. It keeps the books with perfect, cold, and eternal accuracy. Every atom we synthesize, every single layer of plastic we bury, will be the primary data point for those who study the Earth long, long after we have turned to dust, which leaves us with one final, stark reality to ponder. As the primary geological agents of Earth, actively writing the rock layers of tomorrow, are we really ready to face our final planetary audit?